Okay, so this is the last lesson that we have for this unit. You guys are going to be testing next week, most likely on Tuesday, although the rate that we're going at, we might be able to test a little bit sooner than that. Depends on how we do with our assignments tomorrow. But anyway, what we are doing for today is we are focusing on the graphing and comparison of proportional relationships given the values for our slope. So our learning target for today, I can graph and compare proportional relationships and interpret unit rate as a slope. So remember last semester we talked a lot about proportional relationships, and there were two very key characteristics for graphed proportional relationships, two ways that we identified that a graph was proportional. Who can tell me one of those characteristics? Io? Has to be a straight line. Okay, remember we call that linear. So it has to be straight line or linear. And what else is it, Vincent? It crosses through the origin. So in order for it to be a proportional relationship, it one has to go through the origin. So just put origin. And then two, it must be linear, which means straight. Okay, so those are two very important characteristics to make sure that you understand. And then we also had an equation that we had created from it. We had indicated that there was the equation y is equal to kx. Y is equal to kx. Okay, where k represented our direct variation or our constant of proportionality. Okay, now with in regards to slope, instead of us saying y is equal to kx, we're now going to change that into what we call y equals mx, because there is an equation called slope-intercept form, which is y equals mx plus b, where m is going to actually represent the slope. Now, we're not going to worry about the plus b or the minus b in this portion because we're talking only about proportional relationships. Harper? We're only talking about proportional relationships, which means that our y-intercept is going to be at 0 because it crosses through the origin. So we're just focusing on the equation as y is equal to mx. Okay, and again, m is going to be representing our slope. So given this following situation here, we have Michelle. She uses beads to make bracelets, and for each bracelet, Michelle uses red beads and blue beads. And the ratio of red beads to blue beads is 3 to 2. So that means for every 3 red beads that she has, for every 3 reds, she's going to have 2 blues. That's what this ratio means. For every 3 red beads that she's got, she's creating 2 blues to go along with it. And so what we want to do is we're going to graph the line that shows the proportional relationship between the number of red beads and the number of blue beads. So notice that red beads is going to be represented as our x, and blue beads is going to be representing our y. So we know that if she doesn't have any red, she's also not going to have any blue because we're graphing a proportional relationship. So we know it has to start at 0. It has to start at 0. Okay? Now, if I were to go ahead and graph the next point, it says that for 3 reds, she's got 2 blues. So if I follow along where 3 reds is going to be, and then I go up to where 2 blues is going to be, that's where my next point is going to be at. Who can tell me what a third point is going to be? What's the next following point going to be on here if we're following the same trend? Isaiah? Try again. Reverse it. 6, 4. Right? So 6 of our beads being red and 4 of our beads being blue. So that would be the next point that we could graph. What about after that? What would be the next point we could graph from there? Mackenzie? 9, 6. So we could have 9 red beads and then 6 blue beads. Okay, so that's following the trend that we've created there. And of course, you know, this is going to be a nice straight line that we've graphed. So So I can connect these points together to create a straight pathway to show that it is a linear relationship. Now, from here, I can identify what my slope would be, because I do want to go ahead and write this as an equation using y is equal to mx plus b. So I need to find my slope. Now remember, slope is going to represent a fraction where we've got our rise over our run. Okay, so what I want to do is I want to create a series or just one right triangle that would connect these 2 points together. So I can create a right triangle located here where I have a height and a base that are going to create this right triangle to connect those 2 points together. Okay, remember that in the pink, that's going to be my rise. So what is my rise right now for this triangle that I created? Carol? Okay, so my rise is a positive 2. Okay, and then my run, what is the run going to be for my triangle? What is the run going to be? Corbin, what's the run going to be for this triangle here? 3. Okay, so we have a run that is a positive 3. Okay, so now, since both of these are positive, I have a positive over positive. That means that the whole thing is going to be positive. So 2/3 is as simplified as it gets. There's my slope. That means that when I create this equation, the equation to represent this situation, I'm going to write it as y equals 2/3 x. So there's the equation to represent our situation for beads, including our slope. And again, like I said, it does not matter which points you pick, they will constantly have the exact same slope. I am always going to be having a rise of 2 to go from one point to the next. I'm always going to be having a run of 3 to go from one point to the next. All of them are going to be the same. So rise of 2, a rise of 2. These ones are going to be runs of 3, run of 3. Okay, and even if I decided to pick my very first point and go all the way to my last point, that would then have a rise of 6 and a run of 9, but 6 over 9, again, would simplify to 2/3. Okay, so it does not matter which points you pick, as long as you make sure that you are doing rise over run. Okay, so let's go ahead and take a look at our next problem. So we're going to be graphing the following proportional relationship we've got here. Tanya exercised for 30 minutes. She noted the calories burned at 3 times during her workout. So she's got 3 different times during her workout that she made note of her calories burned. And we're going to graph the data, and then we're going to use the graph to determine how many calories she would burn after 15 minutes of exercise. Okay, so we've got 10 minutes, she burned 95 calories. At 20 minutes, she burned 190 calories. And at 30 minutes, she burned 285 calories. So if I were to write these all as points, my time is representing my x. Time is representing my x. My calories burned is representing my y. So for this very first time setting, 10 minutes was the x. 95 calories was the y. So that would be the ordered pair that I would have written. For the next set, I'd have 20 minutes for my x, and then 190 minutes for my y. And then for this last set down here, my x was 30 minutes, and my y was 285. Okay, so I can go ahead and graph these points. And again, it's a proportional relationship, so where is it going to first start? At the origin, right? We're going to start at 0, 0. Then we're going to graph where 10 minutes is. We're going to go up to where 95 would be, which is close to the 100 mark. At 20 minutes, we're going to graph to where 190 would be. And then at 30 minutes, we're going to go up to where 285 roughly would be. Okay, so once we've got these graphed, we can go ahead and connect them together. Okay, so based off of this, if I were to create my triangles to be able to identify my slope, I need to identify what the rise is going to be and what the run is going to be when I'm working through this. So for my rise, who can tell me how much my rise is going to be in this situation? Going from 0 to my first point, how much am I rising by? How much am I going upward by? Mackenzie? 90, not 90, but 95, right? We're going from here, from 0, we're going up to 95, right? That was where our first point would be, going from 10, 95. So this is going to be a rise of 95. And then what about the run? What is the run going to be in this situation? Corbin? 10. So our run is going to be 10. Okay, and you could check the rest of them if you wanted to, but they're all the same. They're all going to have a rise of 95 and a run of 10, a rise of 95 and a run of 10. Okay, so now that we've got that, we can go ahead and simplify this. So 95 over 10, that actually simplifies to 19 over 2. So there's our slope, 19 over 2. So that means when we create our equation is just y is equal to 19 over 2 and then x. So there's our equation. Now the question that they're asking though, the question they're asking is to use this equation that we've created to be able to predict how much was burned after 15 minutes of exercise. After 15 minutes. So 15 minutes, is that an x value or a y value? Looking at your graph, is 15 minutes x or y? X, right? 15 minutes is an x value. Okay, if we're looking at our graph says time is our x's. Okay, time is going to be our x's. So all we have to do is substitute. Who remembers what it means to substitute? If I say we're going to substitute this value in, what does that mean we're going to do? Go ahead, Corbin. Exchange it, right? We're replacing it, right? If a substitute is going to be here for me, that means that I'm being exchanged with another person. They're going to be in my place, right? We're going to do the same thing here, except now instead of an x, we're going to substitute 15 in for x. So this x value is now going to become a 15, and then we can solve for the y. So we can do y is equal to 19 over 2 times 15. 19 over 2 times 15. And when we multiply those, we're going to get 142.5, and that's calories. So at 15 minutes, we were able to burn 142.5 calories. Okay, what I want you guys to do is you're going to do this third problem down here where it says Kevin's cereal has 3 grams of protein for every 1/4 cup. I want you guys to follow the directions. You're first going to graph the relationship that's being presented. I want you to tell me what ordered pair represents the slope. Okay, so what value is the slope? What does it tell us? Not the ordered pair, but what value is the slope going to be? And then how many grams of protein are in 2.5 cups? And what does the point 448 represent? So there's 3 questions that were being asked here. So go ahead and do this problem on your own. Okay, so taking a look here, again, it says Kevin's cereal has 3 grams of protein for every 1/4 cup. So when we are looking here, our 1/4 cup is being displayed as our x-axis, and then our grams is being, protein is being displayed as our y-axis. So when we're plotting our points, obviously we first start at 0, 0. It's a proportional relationship. Then at 1/4 cup, it's 3 grams. How much would it be at half a cup? 6, okay. And then at 3/4 a cup, it's going to be at 9. Okay, so there's our graphed relationship that we can plot here. I'm going to go ahead and connect them to show it's a linear relationship. Okay, and then I can show my rise over my run. So every time my rise increases by 3, then my run is increasing by 1/4. Okay, so my rise is increasing by 3, my run's increasing by 1/4. So my slope is going to be equal to a rise of positive 3 over a run of 1/4, positive 1/4. Okay, now we don't leave it in this format. You don't leave it as a complex fraction like that. So you do need to do 3 divided by 1/4 or 3 over 1/4. What would that simplify to? 12. Thank you, Madison. Okay, so that's going to simplify to 12, or 12 over 1. And that's going to represent the amount of grams of protein for 1 cup. Okay, because if we put 12 over 1, it would be 12 grams of protein, 1 cup of cereal. Okay, so now we can write this as a equation, or an equation. Y is equal to 12 times x. And then we want to go ahead and do a little substitution. We want to know how much is it for 2.5 cups. So for that 2.5 cups, we're going to go ahead and replace or substitute the x with 2 1/2. Okay, so we're now going to do 12 times 2 1/2. And when we do that, we're going to get 30. So y is going to be equal to 30 grams of protein. At 2.5 cups of cereal, we'd get 30 grams of protein. And then we want to know, what does the point 448 represent? So what does the value 4 represent in this situation? 4 represents the what? Camila? The cups, right? The cups of cereal. So 4 is going to represent the cups of cereal. And then the 48 is going to represent what? Grams of protein, right? So we get 48 grams of protein. Okay? Any questions? Relatively easy stuff. Go ahead and stop here. We're going to line up for lunch. Okay, taking a look here, the table below shows the relationship between the number of erasers purchased at the school store and then its total cost. So the erasers is going to be representing our x-axis. Erasers is going to represent our x. And then the y is going to be representing, here I'll do it in purple. The y is going to be representing the cost. Okay, and then we are wanting to go ahead and plot the information. So we're going to graph the relationship, identify what the slope is and what does it represent, and then how much does it cost for us to have 10 erasers. So obviously our graph is not going to plot 10 erasers. We're going to have to use our prediction skills by substitution. So we're going to go ahead and plot these points first. So when there are 2 erasers, it costs us 80 cents. So at 2 erasers, we're going to go up to 80 cents. Obviously, if there's 0 erasers, it's 0 cents, so we can plot 0, 0 as well. When we have 3 erasers, we're at $1.20, and when we're at 4 erasers, we're over at $1.60, and then we can go ahead and connect those together to form our linear line. Okay? And notice, even though it did not indicate to us how much 1 eraser costs, our line will tell us how much does 1 eraser cost. 40 cents, right? If we follow it over, because we graphed our line, we connected them. So now with that line graphed, we can look at one eraser and follow it up to see how much it's going to cost, which is the 40 cents for the cost. Even though it was not a point for us to plot, it is a point that we would be able to know. All right, now we have to identify our slope. So you are just going to pick 2 points to travel between. So I'm going to find my rise and my run. Okay, so who can tell me what is the rise going to be? What is the rise going to be? Mason? Okay, so you counted the boxes, but look at the interval. The interval is not 2, right? We're going from, it's what? 0.4. So be very careful, guys. That's a very common mistake that people make, is they're only counting the boxes, but these intervals, these boxes don't represent one whole each. They actually represent 0.2 each of them. So we're going up 0.2 and then going up another 0.2. So that means we're going up a total of 0.4. Okay, so our rise in this case is 0.4. And then what is our run going to be? What's our run going to be, Kevin? Oh, 1. Yeah, because, right, we're going from 2 to 3. So that box actually does represent one whole. So our run is going to be a positive 1. Okay, so we have 0.4 over 1, which is just going to be 0.4. Okay, so now what does that represent? It represents the price per one eraser. So it is 40 cents per one eraser. So that's our slope. Now we want to know what is the cost going to be if we've got 10 erasers. So I want to know how much is it going to be for 10 erasers. So again, we create our equation. Our equation is y equals my slope, which is 0.4 times x. And then we're going to replace the x with 10. We're going to substitute 10 in for the x. So now we're going to do 0.4 times 10. What's 0.4 times 10? 4, right? Just 4. So that's going to represent $4. So 10 erasers is going to cost us $4. Okay, go ahead and do the fare tickets example. Do the example for fare tickets. So if we're taking a look, they already have it graphed for us. So it doesn't matter which 2 points you use to be able to find your slope. So if you use the first 2 points, you would get a rise of 10 and a run of 2. But if you use the second point and the third point, then that would give you a rise of 15 and a run of 3. And then the third point to the fourth point is a rise of 10 and a run of 2. So either way, you could have put 10 over 2, or you could have put 15 over 3. They both are going to simplify to $5, which is $5 per ticket. That's what the slope is going to represent here. So then when we put it in our equation form, y is equal to 5x, we would then substitute 15 tickets in for x to find out the cost. 5 times 15 would give us $75. So that's what you should have gotten for our fare tickets problem. Now, just a quick review when we're comparing things. So this, another thing that we can call slope is a unit rate. So we know this as unit rate from our previous unit. And you guys also know it from unit price. So real quickly, I just wanted to make sure we do a quick review over how to identify unit price, or which one is the better deal, which one is the cheaper deal. So we have a price for apples using Annie's Apple Orchard and then Franklin's Fruit Orchard. So Annie's Apple Orchard says it's going to cost us $7.25 for 20 pounds. And then Franklin's says it's going to cost us $5 for 12 pounds. So we want to know which one is going to wind up being the cheaper price. So remember, when we're doing unit price, what always has to go on top? The price. Good job, Harper. So the price is the value that's always going to go on the top. We're always going to do price divided by item. Okay, we're always going to take the price and divide it by the item. So for our first one, our price happens to be $7.25, and we're going to divide that by 20. Okay, when we do $7.25 and divide it by 20, we're going to wind up getting 0.3625. Obviously, we can't write that as money. So when we write this one as money, this is going to come out to $0.36. Okay, that 2 right next to the 6 tells us we're going to leave it as 36 instead of rounding it to 37. Then we're going to do the same thing for here. We're going to take $5 and we're going to divide it by 12 pounds. $5 divided by 12 pounds, that's going to come out to 0.416, and the 6 is going to keep repeating. So when we estimate that, that comes out to 42 cents. So which one is the cheaper deal? The first one or the second one? The first one. So this first one is going to wind up being cheaper. Okay, so just as a reminder of how we work through things with unit rates or unit prices, you always put price divided by item when we're talking about a unit price. All right, let's go ahead and flip it on over to the last page. So comparing, basically what we just did here with unit prices is we compared two different scenarios, two different prices to identify which one would be cheaper. We're doing the same thing with charts and tables and equations, making comparisons to identify faster rates or slower rates. So here we've got 3 different cruising speeds for airplanes. One airplane is being depicted in a table. One airplane is being depicted by the equation, and a third airplane is being depicted by the graph. So we're identifying what their rates of speed are going to be. So essentially, since these are all going to be proportional units, we're going to identify what their slope is. So here, inside of our equation, we already have the slope. That's the easiest one to be able to identify. That value of 15.75 is going to represent our slope. So our slope is equal to 15.75, and that is kilometers per minute. These are all displaying how fast that they are traveling per minute. Okay, our x represents our minutes, our y is representing the distance that it's covering in kilometers. Okay, now we're going to do the same thing for our table and for our graph. Now, we've never done slope on a table, but we have done constant of proportionality, or sorry, constant rate of change on a table. So when we're talking about a rise over run for our slope, the rise in this case is going to be how your y is changing. So you're going from one point to the other. The rise affects your y. The rise affects your y. So when we're going from 40 kilometers to 120 kilometers, are we increasing or decreasing? Increasing. So I'm going to put a plus sign. And I'm going from 40 to 120. What am I increasing by? 40 plus what will give me 120? 80. So we're increasing by 80. Okay, so I'm just going to focus on one point. It doesn't matter. I could focus on, actually, you know what? I'll do the rest of them too. I'm going from 120 to 240. What am I increasing by there? Not 80, 120. Okay, I'm going from 240 to 360. What am I increasing by? 120. Going from 360 to 480. What am I increasing by? 120. Okay, so the first one increased by 80, but the rest of them increased by 120. That's okay. Now, our run is how we affect the x. Our run is going to be how we affect our x. So for our first x, we go from 5 to 15. That's an increase. And what did we increase by? 10. Now we're going to go from 15 to 30. That's an increase by how much? 15. Okay. From 30 to 45, that's another increase of what? 15. Okay, and we're seeing that pattern here. 45 to 60 was also an increase of 15. That's okay that our first set of values was different than the rest of the values change. Because when we look at them, when we're comparing them, it is going to have a proportional comparison or a similar comparison. If we set this rise up of 80 over 10, hi. Here, let me pause this real quick. So we have 80 over 10 that's been set up. Then we can also set up our other value, which was at 120 over 15. Now again, it's okay that they are different because in the end, they're going to be equal to each other. If we do 80 over 10, Mason, wake up. We do 80 over 10 and 120 over 15, they both are going to simplify to what value? 8, right? That's going to represent 8. And again, we're talking about the speed that it's traveling. We're trying to compare all these 3 different forms for 3 different items. The first one that we looked at here in the middle was comparing kilometers per minute. It's the same thing for our graph. It's going to be 8 kilometers per minute. Okay, now we're wanting to know who's faster. At this point, is the first one faster than the second one? Is 8 kilometers a faster speed than 15.75 kilometers? No. So right now, I don't have to worry about this one anymore. Okay, when we're comparing 3, I know comparing 3 different kinds of representations can be a little daunting, but if you take it one at a time, it's not so bad. We know that we no longer have to focus on this one. It's not the highest. Our equation for the Boeing happens to be the highest right now for its slope. Well, now let's take a look at the jet airliner. Okay, again, we're going to identify the slope, the cruising speed that we're traveling at. Okay, so when we're doing that, we notice our rise over our run. It's the same that we've been doing for the past couple of days. We're just going to identify how much we're going from one point to the next. Does it matter which one of these points that I start with? Can I start at the origin? Can I start at the origin? Wake up, guys. Okay, they were perfectly fine before you all come in. You can start at the origin, or you can start at 460. Okay, it does not matter which one of the points you choose. I'm going to go ahead and we're just going to use these 2 points that have been presented to us. So we're going to have a rise, which is our vertical change, and then our run to represent our horizontal change. Who can raise their hand and tell me what the rise is going to be to go from this point to the next, Vincent? Okay, so our rise is going to be a 30, right? We were at a level of 60, and then we increased to a level of 90. So our rise is a change of 30. And then what about our run? Our run is a change of what, Tyler? 2, right? We started at 4 minutes and then we increased to 6 minutes. So our run is a change of 2. Okay, so now we just have to go ahead and simplify that. 30 over 2 simplifies to, Isaiah? 15. Okay, and again, we need to make sure that we are presenting it in its units. So it's 15 what? Kilometers per minute. Good. So we have kilometers per minute. Now, we already said that we could get rid of this first one. We knew that that was the slowest. So now we're only having to compare these two. So which one's faster, our Boeing or our jet airliner? Io? Our Boeing. The Boeing is going to be the fastest cruising speed. Okay, so this one is our fastest. All right, I want you guys to go ahead and attempt the same process. You're going to do that for our next example, where you are comparing the rates, the prices that it's going to cost per hour for us to be able to rent a canoe. So you have one representation in a graph, one representation that is not in an equation, but it is giving you a ratio, and then one representation in our graph form. We're going from $18 to $27. That change is going to represent our rise. So from $18 to $27, it was an increase of 9. Same thing when we go from 27 to 36, that was an increase of 9. And then when we go from 36 to 54, that was an increase of 18. Again, it's okay that they're different because in the end, they're proportional to each other. Okay, they're equivalent to each other. If we're taking a look at the change that's occurring for our run, we're going from 1/2 to 3/4. 1/2 to 3/4. That's an increase of 1/4. When we're going from 3/4 to 1 whole, that's an increase of 1/4. And when we're going from 1 to 1.5, that's an increase of 1/2. So again, when we're looking at these equivalent forms, I can put them both in different formats. I can say, hey, I'm going to do 9 over 1/4, or I can do 18 over 1/2. They're both going to come out to the same thing, which is $36. And that's representing $36 per hour to be able to rent that canoe. Okay, now we're going to look at our second form. Our second form is not an equation like the first example was, but it is giving us a cost per a certain amount of hours. So we can go ahead and set that up as this being our rise and this being our run. We can take that $98, that unit price that we're going to solve for, and divide it by the quantity, the number of hours that it costs us. So 98 divided by 3.5, that's going to come out to $28 per hour. So far, which one is the best price? The Outdoor World. So we no longer have to worry about Kara's canoes. Okay, so now let's take a look at this last one. For our last one, you're just finding the rise over run between the 2 points. So we have a rise of what? How much are we going vertical with? Jalen? 25. We're going up 25 units. And then our run in this case is how much? Our run is going to be what? Vincent? 1. Okay, so we have 25 over 1, which is just going to come out to $25 per hour. $25 per hour. So between Outdoor World and Rec Place, which one is cheaper? Rec Place. Okay, so this is our cheapest. All right. So let's take a look at this last example. We're comparing some speeds. One speed is given to us in word format. So it says Mark drives 6 hours at a constant rate and travels 408 miles. Fiona is going to be represented by the graph. We want to know who is driving at a faster rate. We want to know who's driving at a faster rate. Go ahead and do this one on your own. Let's talk about Mark. Mark drives 6 hours at a constant rate and has traveled 408 miles. What are we going to put on the top? 6 or 408? 408, right? That 408 is going to represent our rise in this case. So we're going to put 408 on the top. On the bottom, we're going to put the 6 hours. That's going to represent the run. So if we do 408 and divide it by 6, that's going to come out to 68. That represents his miles per hour that he's traveling. Okay, so in order for Fiona to be faster, does she need to have a miles per hour that is smaller or larger than 68? Larger. In order for her to be faster, it needs to be larger. So now I picked 2 points. You could pick any 2 points that you want. For Fiona, her rise, I went from 130 to 195. When I go from 130 to 195, that's an increase of 65. So I have a rise of 65. And then the run is going from 2 to 3. So that's just a change of 1. So 65 over 1 is just going to come out to 65 miles per hour. So Mark is going to be the faster one. All right, you do not have homework tonight. You will have an assignment in class tomorrow.